if you, in order to understand what's the main point of the project, I will make you a question, right? When did you fly last time? You took an airplane. Just think about it. Maybe it's last summer when you went on holidays, or maybe it's last month when you went on business trip, or maybe yesterday, I don't know. Anyway, you are flying much more often than 20 years ago, not to mention 30 years ago when it was the Iron Curtain. That was not easy to travel at all. But not just flights are more frequent, flights are also, in average, longer. In order to illustrate that, I will show you something that was almost impossible to see 15 years ago, but now you can see it every summer in Bratislava, which are Asian tourists. Here looking at this statue of the man at work. And this is just the beginning. Every day there are more and more people developing countries that can afford to fly. We just look at two particular countries, which is China and India. They have 5 times the population of the European Union. So just a portion of these people can fly as often as we do. That's really a lot of emissions, right? So the European Commission wants to reduce these emissions, and that's why they have these acre flight paths emission targets. And these are the targets normalized to the year 2000, 75% reduction in carbon dioxide, 90% reduction of nitrogen oxide and particulates, which cause cancer, and 65% reduction of noise. These are really drastic reductions, and they need drastic improvements. And the improvement that will achieve that is what's called hybrid or electric distributed propulsion. This is one concept from Airbus, where you have a gas turbine generator that generates the electricity, and this electricity goes to the superconducting electric motors, which are connected to a fan that generate the thrust. In this way, you don't just have more efficient motors, you also can change the whole design of the whole airplane. You can improve the aerodynamics, you can improve the lift of a drag ratio. And basically the idea is that when you use conventional combustion turbines, they need to be large in order to be effective, right? So you can have 2, or if it's a huge airplane, you can have 4. And usually for the short flights, up to 3,000 kilometers, there are only 2. But this doesn't happen with electric motors. They have more or less the same efficiency of any load, so you can make many smaller ones and change completely the design of the airplane. So basically, I will explain a bit more about this hybrid concept. There are many kinds of hybrid propulsion. I will explain this one, that you have some generator that burns fuel and, well, some turbine that burns fuel and generates electricity. Part of the electricity could be also from some battery, and this electricity goes to electric motors. There should be actually superconducting motors, as I will explain later on. Well, what's important? I'm sure that something like that would happen. If it doesn't happen in Europe, it will happen somewhere else, because in NASA and Boeing and the United States, they also have similar concepts with an airplane with superconducting generators and many small superconducting electric motors. So in order to keep the leadership of Europe, or competitiveness in Europe, so it's necessary to do something. And what we do is this project, Advanced Superconducting Motor Demonstrator, that will consist on the following. So the structure of the talk is the following one. I will talk about the project, and then I will make you some remarks on or recommendations about the Future Horizon 2020 project. So about the project, I will explain the goals, why to use superconductors, which is our consortium, and what's our role. So the goals of the project is a superconducting motor for lab demonstration for 1 megawatt and 20 kilowatts per kilogram. That means it will weigh around 50 kilos. It's possible to hold it with both hands if you are a bit strong. And to have an idea, the size and weight, it could fit in the engine part of your car, but with 10 times its power of Of course, it's not designed for that, but it will have 10 times the power of the motor of your car. This figure is very challenging. State-of-the-art conventional electric motors are about 5 kilowatts per kilogram. Right? So that's the order of magnitude. And a conventional synchronous motor, it could be like that, it's one type, where you have some iron parts, also some copper. This is what is called a stator, that's the part that's not turning or not moving. And you also have permanent magnets in the rotor, which is the part that actually moves. But in order to get sufficient power density, you need superconductors, and I will explain why. You can change the copper in superconductor, and in this way, superconductor can carry much more current density. So just to illustrate, you have this copper to transport 200 amps, and actually only one of those superconducting wires is enough. So you can put more current and increase the power of the stator. Just for curiosity, this superconducting tapes is a multi-layer structure where the superconducting layer is 2 micron thick and it's 4 millimeters wide. So 2 micron thick is maybe the size of a bacteria, just to have an idea. But you need low temperatures. Nothing comes for free. And high temperature superconductors, like the ones we're going to use, are superconducting below 90 Kelvin. But you maybe need to cool down further for the performance. Maybe 20 Kelvin,